Yes, so this is how you're going to use our tutorials and our PyHealth. And yeah, here is a tutorial that here is the main web page of PyHealth, and then you can go to, and the left-hand side is the navigation bar. We have for different tutorials ready for different models, and the tutorials for how to build a complete pipeline for PyHealth, and some advanced tutorials to cover different use cases. And these are the documents for the different modules in PyHealth, and each of them have some specific examples ready for you to check out, like this, the models, like retain. Okay, and here are some additional information. We will we will put the future schedule of PyHealth here, and then here are some informations about our PyHealth live, weekly live. We also put our development log here for you to check out what are the new functions that has been added recently. So today I'm going to go over the tutorials for how to build a complete pipeline. I'll just randomly click one of them because all of them have the same kind of setup. I will choose the second one, length of state prediction. Okay. So the first step of using PyHealth is just use pip install PyHealth, and then you will have the package locally. And then today we'll go over step 1, step 2, step 3, up to step 4. Each step is enabled by one module in our package. Let's go to step 1 to load the dataset. And then I'd like to show you in the real application how you're going to deal with the dataset. So in real application, what you will see is like this. Let me quickly get the data that you probably will see in your application. So here, what I have shown is a synthetic mimic-3 dataset, because we are not allowed to distribute the real mimic-3 dataset. So we create a synthetic mimic-3 dataset that has the exact same structure as the mimic-3. So this is the data that you will see when you want to do some task. You will have different .csv files for different information, such as the admission information for all patients, or the lab information, the patient information, prescription information for all patients. And then if you want to build some models on top of it, you have to do some data processing to clean the data, to create the training samples and test samples, or etc. So what our PyHealth can do is that we already provide these mimic-3 datasets, these APIs for you to call, and we will clean the dataset and then store it in a very well-structured way. And then later on, you can query the data very easily. So to use our API, there are some arguments that you need to specify. The first one is the root of your datasets. The root is just like this. This is the open link everybody can access. This is like the root path to the folder I just shown you. Just specify the root to us, and then tell us what tables that you want to process for your downstream task. I can enlarge it a bit. Yeah, so this, for this argument, you have to input a list, and then in this list, each of the item will be the row table name, and they correspond to one of the table here. Okay. And then we also support the code mappings, but right now in this task, it's not used. So we input an empty like argument. So in some other cases, if you wanted to do code mappings, right now, since we already input prescriptions, can run it to save some time. So we already put a prescription tables, and then in the mimic-3 structure, these prescriptions, the drugs are coded in NDC system. And then if you, for some purpose, wanted to transform the code to some other coding system, such as ATC, you can just use our argument like this. This will enable you to transform the NDC code to ATC 3-level code. This is the argument for ATC. So if you want to transform from NDC to, for example, RX norm, just do like this. Okay, so in this application, we're not going to do this code transform. For the purpose of doing code transform, yeah, I will like mention the purpose in another task if we still have time. So the last argument div development is more a argument for demo purpose. So if it sets true, then we will only load a small set of patient. If it's false, then we process the whole data set. So in our case, we will set it to true, and then the patient will processing is just the first 1,000 patients because we want to save some time on data processing. And okay, it's almost finished. So I'm going to show you what is the resulting structure. Visually, the resulting structure will be like this. We will clean the data set and store it in this way. It's a multi-level structure. We will provide a dictionary for patient. The key is the patient ID, and the value are each of the patient objects. And within each patient object, we store these patients and hospital visits in time order for you. And then within each visit, we store different information aspect here because we process the diagnosis procedure and the prescription tables. And then under this hospital visit, we will have a like diagnosis and procedure and not lab test, but prescription event list like under the hospital visit. Okay, we have finished the processing. So after calling our API, we got this mimic3_ds object. You can use .stats to access the statistics of the processed data set. So right now we can see that we have 1,000 patients because we use the development mode. And then we have this many visits. So apparently, most of the patient only has 1 visit. And here are some statistics for the information tables that we just inputted. Okay, if you wanted to know the real structure of the object, just use .info function. So we have this information here. So to access the information inside of this large object, I will teach you how to do that. So you got this mimic3ds object. Just use patients. Patients, you will get a patient list. And then let's say we randomly select a patient, for example, this one. Input is ID, you got that patient's object. So this patient only has 1 visit. We use .visit to access it's the patient's hospital visit. So this hospital visit ID is this. We access the visit like this. So okay, it tells us that this visit has 3 table information. It contains the diagnosis code, procedure code, and prescription code. So we wanted to get the procedures, for example. Then how to do it? We just use get code list. Okay, it outputs a list of code for procedures. So these are like 2 procedure events following the time order in that hospital visit. We can also do like prescriptions, see how many prescription events are there for this patient. Okay, there are a lot of medications prescribed for this patient. Okay, you can stop here. Let me just delete this one. And then after we got this object, we are going to define a healthcare task on top of the object. Okay, so in this demo, I'm just going to import a example function, which is length of stay prediction function on mimic3, and then directly use this enlarge set task to use a function to process these data sets. Okay, for adding prefix noise. Okay, after this process, we got a task dataset. We can access the statistic of this task dataset by .stats, and then it tells us, okay, we have got almost like 900 training samples, and then we have this many patients. So some patients cannot generate samples for some reasons, and then for the condition features, we have this many, and then here is a distribution of different condition code. And for procedure features, we have this many. Here is the distribution. And for the labels, which is the length of stay prediction, length of stay label, and then we have 0, 1, 2, 8, 3, something like that with the distribution. Okay. So if you are curious about what is this function, I can tell you where to find it. You just type PyHealth, PyHealth, and then go to our task, find the length of stay prediction on mix3, click the source. So of course we have give the definition here, but if you can go to the source and then you'll find how we define our labels. So we first you just read these 2 lines of code and then to treat them as the pseudo code. Okay, so what we do is we first obtain the length of the hospital visit, the discharge time minus the encounter time, and then the days to get the length. And then we input the days to this categorize loss function. So if this patient stay in ICU and shorter than 1 day, then we output 0. If he stays for like 1 up to 7 days, we just output days. If he stays more than 1 week but less than 2 weeks, we output 8. Otherwise, we output 9 if he stays for over 2 weeks. Okay, that's how we define the labels. So for the length of stay prediction, this is like a 10-class classification problem. So if you can just go to this statistics and see the distribution of labels, we can see 0, 1, 2, 3 up to 9. Yeah, 10 labels. And it's like imbalanced data. Like the label distribution is not balanced. Okay. Yeah, so what this function is doing is that this function will define that healthcare task and then process the dataset we just get in step 1 and then make it to be a task dataset. So in this task dataset, the only information we have is dot samples. That's the samples we are ready to use for machine learning models. I'll just show you the first sample from our process, okay? So this is a task. Okay, this is just one sample, and in the sample we have several attributes. We have the visits information for this sample. We have the patient. So this sample is from patient 1, and from the patient 1's this visit. Okay, and then for this sample we have the condition features, which is a list of code, and we have the procedural information, which is like this, still a code, and we have the prescription information, which is a drug. We have this, and the labels are just the length of stay label. Okay. Then apparently these 3 conditions, procedures, drugs can be the features for us to use, and the labels are the things that we want to predict. Okay, the next step is like universal in this package. We use we will not change the code here, maybe change some parameters. So what we are doing here is to we already got the task mix3 underscore ds dot samples. We have a data set ready. We want to split the data set by patient, split some patient into training, some patient into validation, some patient into test. And we are making sure that there is 1 patient only appear in one of the sets. And then we do this split by 80%, 10%, 10%. And then we, so we load each set into to be this torch.data loader and assign the batch size whether to shuffle or not. So these parameters are the same as this torch.data loader. Okay. So I'm going to run it. This is a task. Okay. So from task 1 to task 2, sorry, step 1 to step 2, we have finished the data processing and we have got the data loaders. Now we are ready to define the machine learning model. Okay. So here in this task, we call this retain model. And this retain model is a very general model for, it can be used in different tasks. So to select a model, you can find our PyHealth and go to this model page, and there is a different model for you to choose from. Some are general models, but some are specific models for some tasks. Okay. Here we choose this retain. And yeah, I can also change it to be a transformer, something like that. And then the arguments will be exactly the same. The first thing we need is the dataset, the mix3 dataset we just processed. The second thing we need is the feature keys. So here we choose the conditions and procedure as a feature keys, which should be aligned with the name here. So we are going to tell our model what are the keys we want to use for feature. Okay, so the labels are of course our target key. Yeah, so the labels is a target key, and then these two are the feature key. And the task mode is multi-class classification. We're going to initialize this model. Of course, we can like specify some other parameters for these transformer models. We can just check here what are the parameters that are allowed to add for transformer. Check here. Okay, we can specify number of layers, drop out, how many has for the multi-head attention. I will maybe randomly pick one and put it here. We use 2 layer, okay. And then right now we have initialized the model, and we are going to train the model, okay. So our trainer is similar to the PyTorch Lightning. You just need to initialize our trainer and give the model to use the model as an argument to initialize the trainer, and then use trainer.train. We have to specify the training loader, the validation loader, and how many epochs we want to run, and what are the metrics we wanted to monitor. So here we want to monitor the accuracy. So before I doing that, I will have to check the trainer and then tell you how to set this monitoring metric. Okay. So this is here to initialize the trainer. We have a metric argument to use. It says that it's a list of metrics name to be calculated. So by default, this accuracy is already included into this model monitor. Okay. So there should be something including accuracy. But if we don't specify accuracy, it's already a default value here. Okay. I'm going to make these epochs smaller, for example, 5. Right. Okay. Start to train. You can see that this loss function is going down from 4 to 3 to 3.1 to 2, and we stop. Okay. And then in the end, we will load the best models according to the accuracy of the validation sets. Okay. And to evaluate the model, there are actually several options. I will just show 2 options here. One option is to use trainer.evaluate and tell us the test loader, and that's it. Right. Okay. You got the score. So this is the result you get from the first option. Okay, there is also another option to use, which is for that you have to use our PyHealth.metrics.multi-class classification. That's the module to evaluate multi-class classification. Okay, you will input this multi-class metrics underscore function, and then first use the trainer.inference, and then give the test loader. You'll get the true label output and the probability output and the loss. Okay, then pass this true label, the probability, and also tell this function what are the metrics you wanted to calculate. So to really know how to use this function, you can just go to our webpage and then check this metric, multi-class classification, and then here are all the metrics that are available for you to use. And we also provide an example. Okay, follow. We just like use exactly the same way as what the example has shown. Okay, and I can like add one more metrics. Example coherence kappa. And here, okay, show up. So this is a more flexible way of how to evaluate the performance. Okay. And in fact, here, this monitoring metrics is the same as the metrics we list here. You can just add one more, such as a JCAD weighted to monitor. And then here you can use JCAD weighted as the criteria to choose the best model. Let's run it again. Okay. And then the same, we can evaluate. Okay, so that's basically it. for this whole pipeline. So this is for the length of stay prediction task. I just shown you the 5-stage pipeline. Actually, I can stop here and then maybe show you another one. Let's say we wanted to do a drug recommendation. Okay. Still, the first step is to pip install PyHealth, and then there are 5 steps ready, the same as the previous pipeline. The first step is still to load the mimic3 dataset. Of course, here the synthetic mimic3 and the exact same argument, but except that here for this task we use the code mapping to map the NDC code to the ATC3 level, because as you know, the NDC code are very fine granular. It has like tens of thousands of millions of code, but ATC level is quite small, and it's quite 3 level, quite small, and it's quite code granular for predict the drugs. If the space is smaller, then the accuracy will be better. So that's the purpose of doing code mapping here. I will not run the code, I'll just show you the output of each cell. Okay, the same here. You can use .info to access the dataset object you just obtained, and this is the structure you get. And then here for this task, we have to input another healthcare task. Okay, so if you are curious of how to like implement this function, just go to our live session and check which session. Else. So in live session 2, we have covered that. You can just go there and then check the video. Or in session 8, we are also going to mention this in more detail and give more examples. Okay. If you are really interested in it, just click one of the, for example, drug recommendation, and then see the source code to read it. It's very short, and then the main idea is to process the data and to like combine information together as information as this machine learning sample. Okay. So this is the second step. You input a function from a task, or you define your own function, and then set the task to the dataset. Then you will get the samples. Then do data splitting and load it into the data loaders. That's the second step. The third step is to initialize a model. Here we still use a transformer, or we can use other special model set, such as safe drug, GameNet, and then the argument is the dataset you just processed the features you wanted to use to predict the label, and then what is the mode for your prediction task. Here for drug recommendation, this is a multi-label prediction task, and then we do the model training. We monitor another metric, and we do evaluation. Yeah, so that's basically it. For other like pipelines, they have this exact same structure, but probably with minor changes on hyperparameters, and of course the healthcare task function is changed. Okay,